All right, so in this first unit in trig, we are going to be looking at sets of data. And what the goal is when we look at a set of data, we're going to figure out, okay, which function model best matches the data. And in this unit, we're primarily going to be looking at three different function models. We're going to look at linear, we're going to look at exponential, and we're going to look at quadratic. And we're going to start by looking at linear. That's going to be the first function model that we're going to look at. And so today we're going to be talking about linear models and whether or not there is a linear correlation. And we'll even talk about something called a correlation coefficient. All right, so we're going to start off by looking at a graph. And right here I've got 4 graphs, and we're asked when we look at the graphs to decide if there is a strong negative, strong positive, weak negative, weak positive, or almost no correlation. So let's first talk about what we mean by strong versus weak. Now for all of these, we're talking about this in terms of linear regression. So a strong correlation would mean it forms a line. Now, not a perfect line, but it looks like it's, the graph looks linear for all intents and purposes. If we had to say, what's the general shape of the graph? The general shape is linear. We say it's weak if it doesn't form a line at all. Doesn't look like a line. Okay. So that's the strong versus weak. The other thing we have to talk about is positive or negative, and many times with linear we also use the terms increasing and decreasing. So when we say that something is positive, I'll use a plus sign for that, okay, positive, that means it's increasing. And when it's negative, that means that it is decreasing. Now it's also very important for us to note that whenever we read a graph, in order to determine if it's increasing or decreasing, you always read a graph left to right. So let's look at number 1. When I look at this, they're all called scatter plots. When I look at this scatter plot, it truly looks like a scatter plot. It just looks like a bunch of dots all over the place. I couldn't tell you if it was going up or down. It just looks like a big blob of plots. When it looks like that, I would have to say this looks like it has almost no correlation. So I'm going to put the letter E for that one. All right, then when I come down here to number 2, and I look at this, it looks like the dots going left to right are definitely going down, decreasing, so that's negative. So I know it's going to be a negative correlation. And it looks like the form of a line, so I'm going to say it's strong. Strong and negative, that's going to give me letter A. Then I come to number 3. Once again, it does look like it's headed in a downward direction, but it doesn't really look like a line to me. So I'm going to say it's negative, but it's weak. So that would be letter B. And number 4. Number 4 definitely looks like it's headed in the upward direction, increasing, so that's positive. And, you know, I could draw a line. Like if I was to try to draw a line, I'd probably go like right through here. So it's kind of strong. I honestly wouldn't say that it's strong or weak. I'd say it's kind of in the middle. But since I could draw a line, I guess since I have to pick between strong and weak, I'll pick strong. And it's positive, so I'm going to go with letter C. All right, so now we're going to come down to our first example. and look at an actual set of data. In questions 5 through 8, heavy metals can enter the food chain when metal-rich discharges from mines contaminate streams, rivers, and lakes. The table below shows that lead and zinc contents in milligrams of metal per kilogram of fish for 10 whole fish, including rainbow trout, 4 large-scale suckers, and 2 mountain whitefish. They're taken from the Spokane River during July, August, and October of 1999. All right, it says use a statistics utility. Just want to clarify what that is. That is a fancy term for a graphing calculator. So whenever you see them say use a statistics utility, don't let that throw you off. That's simply your graphing calculator. So you are going to need to have that available. All right, next. To find an equation of the least squares line. That is, again, a fancy term for either linear regression or what you might have first learned as line of best fit. To predict the amount of zinc from the amount of lead. All right, it is important here when they say predict the amount of zinc from the amount of lead, because in a problem like this, we have to determine which one is independent, or X, and which one is dependent, or Y. And we have to know, is it the lead or the zinc? Well, because it says predict the amount of zinc from the amount of lead, that means the lead is what we're looking at first. And remember, independent, gotta remember this from last time, independent comes first. So that's going to be my X, and that's going to be my lead in this instance. And my Y, which is dependent, in this instance is going to be my zinc. So what I'm going to do now is I'm going to take this data and I'm going to enter it into my graphing calculator. All right, so I'm on my graphing calculator, and I'm going to be putting my lead in as my independent, or X, and my zinc in for my dependent, or Y. So in order to enter data into the calculator, I need to go to Stat and Edit, so I hit Enter here. And L1 list 1 is my independent variable, and this is where I'm going to type in my data for my zinc. So you can go ahead and do that. And then you're going to put your zinc in for your Y. So L1 is lead, L2 is zinc. Okay, so now that you've entered the data into your graphing calculator, if you haven't completed it, just pause the video, type your data in, and then continue playing it. And at this point then you have all of your data entered into your calculator, and now you want to find that least squares regression line, that linear regression or line of best fit. So now we're going to go back to Stat, and then we're going to go to Calculate, arrow over to Calculate, and because we're doing a linear regression line, we're going to go down to number 4, choice 4, and we're telling them to use the X is L1, the Y is L2, so I need to arrow down to Calculate and hit Enter, and I get my least squares regression line. All right, and so A is, let's round to the nearest thousandth. So we're going to go up 3 decimal places. So I'm going to use this information to write my least squares regression line. Okay, so using the information off of my calculator, I'm going to write that equation, which is Y equals 28.725, or 725 thousandths, X plus 19.5 5, 4, 5. All right, and remember X, we said, is lead, and Y is zinc. I like to always label my equations with what X and Y are. All right, so now it asks us to use a statistics utility to find an equation of the least squares line to predict the amount of lead from the amount of zinc. So from the amount of zinc. So in this instance, zinc comes first. And because of that, what we're going to have to do is we're going to have to have zinc, your X, which is your independent, is now zinc, and your Y, which is your dependent, is now the lead. And so now what we're going to have to do is go back to our graphing calculator, and we're going to have to make that change. Okay, so this is where we were on our calculator, and I want to talk about how we can make this change. And it really does depend on which version of the graphing calculator you have. If you have an older version, you might have to simply go in to stat, and you're going to have to edit, and you're going to have to delete each of your columns and fill them in reverse order. Like all of these values here from L2, you're going to put in L1, then you're going to take all these values here in L1, and you're going to put them in L2. So some of you are going to have to do that by hand. However, if you have a version that when you go to Stat, and you go to Calc, and you choose Linear Regression, if your screen looks like mine, where it says X list and Y list, and you can change these, what I can do is say, well, let my X be my L2 column. If you go over here to your graphing calculator, I see that my L1, L2, L3, etc. are written in blue. So what I'm going to do is hit the second button because it's blue, second, and I'm going to do 2, and that will change that to L2. I'm going to arrow down to my Y list, and I'm going to tell it to be L1, so I'm going to hit second, L1, and now it has switched my X and Y lists. Now I can arrow down to calculate, hit enter, and it now gives me a new linear regression line with the zinc being the independent and the lead being the dependent. So I'll write that down for that next question. Alright, so using my graphing calculator, my new equation is going to be y equals 0.031x minus 0.411, and I want to specify that now my y is my lead and my x is my zinc. Alright, now let's look at this. It says number 7, are your answers to parts A and B the same? Well, I can look at my equations. They definitely are not. No, they are not. And I'm not sure if you're aware of this, but whenever you switch x and y in a function, that's called inverses. So they are inverses of one another. All right. So the next question, question 8, says, use an appropriate equation to predict the amount of zinc in a fish that has 2 milligrams per kilogram of lead. So you need to use one of your above equations and figure out the amount of zinc in a fish that has 2 milligrams of lead. I'm going to let you do that, and then we'll come back. All right, so I put the 2 milligrams of lead into the first equation. So I had y equals 28.725 times 2 plus 19.545 I used my graphing calculator and I got 76.9.